Hey, it's Mr. White, and I'm here to show you a new form of factoring that kind of is a buildup of the ones that we just covered. The difference here that I hope you notice is that we've got a number now hanging out in front of that first variable, okay? And so we've got to add an extra step whenever we factor this. So we're going to make our x like we have done in our previous form of factoring, where something's going to multiply to be a number and add to be some other number. And 11, our central term, I'm going to use the highlighter here, but not in ugly green. Oh, beautiful. That 11 right there is going to be what we add. But for our multiplication, we're going to use the first term, the first coefficient and the last term. Those are going to be multiplied together. So what ends up being in my top is actually negative 60. Okay, 12 times negative 5. And so I need to come up with something that multiplies to be negative 60 and adds to be 11. And that is going to be 15 and negative 4. So I'm going to use those numbers with a box. And you may have seen this box before. So my first term is going to go in this box. And that is the word first. If you're writing with your finger like I am. So the first term, and then the third term is going to go here. And then these two numbers with an x are going to go here and here. Okay. So I'll put my 12x squared in, I'll put my negative 5 in, and then I'm going to put my 15x and my negative 4x. And then what I can do is use this particular box and find greatest common factors for each row and each column. So if I'm wanting to find the greatest common factor of this row, a little highlighter heavy on this, but sorry about that, then that would be 3x. If I do it on the row below it, it's only going to be negative 1. Now I can actually go up and down. So, because, it's impossible to have too many highlighters, let's break out another one. Pew, 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 pew. Okay, so if that is what I'm trying to find the greatest common factor of, it would be 4x. And then I've got over here, I'll get a 5. And so 3x minus 1 from the left and 4x plus 5 from the bottom are what I get when I factor. So let's try another one just to make sure you got it. So again, I'm going to use my x to start with and find numbers that add to be 7 and multiply to be 2 times negative 4, which is negative 8. Well, that's going to give me 8 and negative 1. So then again, in so many colors, but this is going to go in my first box. This is going to go in my last box. And these two numbers are going to hang out in my other two boxes. So I'm going to get 2x squared. I'm going to get negative 4. I'm going to get 8x and negative x. All of those coming from those different locations. Now, again, find the greatest common factor across the top. Find the greatest common factor across the bottom. So I get 2x here. I get a negative 1 there. I get an x here. And I get a 2 here. And so I get 2x minus 1, x plus 2. And I want you to make sure you notice, if I multiply this times this, I get negative x. If I multiply 2x times 2, I get not the right answer because, because this was 4, not 2. Don't you love it when Mr. White records a video and does it wrong? But anyway, and that's the way to check your answer, make sure you did it right, is to make sure that those line up. So maybe I even did that on purpose. I wish I could get away with saying that. But that is how we factor trinomials that have a leading coefficient other than 1. So hopefully you're able to take this knowledge and apply it in some practice problems.